All right, guys, we are starting a new little mini chapter. Actually, this chapter only has 3 sections in it, and it's one of those things that typically I would have did at the end of the first semester. We just didn't happen to be there, and it's okay. But I wanted to just touch base on this before we move into chapter 5, which honestly is going to be a pretty good sized chapter, a lot of in-depth stuff. So I want to make sure to try to get this in beforehand. The other reason I wanted to do this was because that this is something that you will see in college algebra, and it's not that difficult. It's just that it's one of those things for some unbeknownst reason that they decide to capitalize on and make sure to make a point and a priority about. So I want to make sure that you know how to do it before you get into college algebra. Again, that's kind of my mission, is to make sure that you're ready before you hit that, and that you have seen or been exposed to at least as much stuff as you can before you get into college algebra. So without further ado, 2b, this is kind of like chapter 2b.1a, is function operations. It says I can perform basic math operations, add, subtract, multiply, and divide with functions. I want to go ahead and say that as well, that really no matter, even if you're going into calculus level math, it all really comes down to these 4 basic math operations. So anything you're doing, you're going to still always come back to those 4 basic operations. So let's suppose that we have 2 functions. Let's suppose that we have f of x equals 3x plus 6. And let's suppose the other function, we'll call it g of x equals 6x minus 9, okay? So we have 2 functions here, and so we're going to perform basic math operations on those functions. And here's the way they will word these to you. So number 1, let's say, they are going to express it this way. They will have f plus g of x. Okay, that's the way you read that, f plus g of x. And they're going to say, okay, what does that equal? Well, basically, all you have to do in this context is you're taking f of x, which is this function. Okay, let's do that in a different color, which is 3x plus 6. Okay, and you are adding to that your g of x function, which is 6x minus 9. Now, you remember when we talked about complex numbers, we've talked about it several times. When you have addition between these parentheses doesn't really mean anything, but it's a good habit to kind of do that just so you can segregate one area from the other. But in this particular case, these doesn't really add to or take away from the problem. Okay, so we could go ahead and rewrite this again as 3x plus 6 plus 6x minus 9. And then again, all we're going to do here is we're just going to look for like terms. So if you notice, I've got a 3x and I've got a positive 6x. So 3x plus 6x would be 9x. Oh man, I'm running out of colors. All right. And then my other like terms here, wow, that's crazy, would be rainbow colors like that. Plus 6 minus 9 is going to be a negative 3. Okay. So basically, if I was looking for f plus g of x, ladies and gentlemen, it is quite this easy. This would be it. Okay. So let's look at another one. We're going to use this same set of functions up here. We're going to use f of x and g of x, e of x, just like we did before. So number 2, though, is going to be f minus g of x. Now, what I want you to remember before we even start on this is that subtraction is not commutative, okay? So what that means is that order does matter, okay? And you're going to see that even more in this next section that we're going to be looking at, but order matters. So it matters whether I do f minus g or g minus f. So I have to really pay attention to what's being asked of me. So I'm being asked to take f and subtract the g function from it, okay? So again, I'm just going to get into a good habit of doing 3x plus 6 in parentheses. This is my f of x function. And then I'm going to subtract from that my g of x function, which is 6x minus 9, okay? So again, when we're talking about subtraction, now all of a sudden, this does matter, and the fact that it's in front of parentheses. So let's rewrite this. So 3x plus 6 is just going to come down the way it is. But now I am subtracting 6x. So subtraction is a negative. A negative symbol and a subtraction symbol is exactly the same. So I'm subtracting 6x, and I am subtracting a negative 9. So if I subtract a negative 9, okay, that's actually going to be a positive 9. So you notice this is kind of like multiplying by a negative 1. It's going to change all the signs that are in here. So now, again, I'm going to do the same process again. I'm going to collect my like terms. So 3x minus 6x is going to be negative 3x. And now positive 6 and positive 9 is going to be positive 15. Okay, so again, this would be my answer of f minus g of x. This would be my final answer that I would have for that one. Okay, so now we're going to use those same functions again. Remember, our functions are right here. These are the ones we've been using, f of x and g of x. We're going to use those same functions again, but this time we're going to do f. Wow, that was crazy. Let me erase that because that was awful. We got f times g of x. All right, so again, our f of x function is 3x plus 6. Our g of x function is 6x minus 9. Again, I've got two binomials here. I have multiplication between those binomials. So you guys should definitely remember by now what to do. We did this in chapter 4. We did it as part of complex numbers as well. Yes, you have got it. We need to use some FOIL, okay? So first times first, 3x times 6x is going to be 18x squared. 3x times negative 9, negative times a positive is going to be negative. 9 times 3 is 27x. 6 times 6x is going to be positive 36x. And 6 times negative 9 is going to be negative 54. And again, my like terms, remember, they're going to be right here in the middle always when I'm multiplying out two binomials. And so I'm going to get 18x squared plus 9x minus 54 as my final answer. Okay? Now, here's the last one we need to do, and then we need to talk about one other little concept before we move on, or before we actually end this one today. So number 4, you guessed it, we did add, subtract, multiply. Now we need to do division. So f divided by g of x this time. And notice and remember that f of x is 3x plus 6, and g of x is 6x minus 9. Now, one may be thinking to themselves, well, I'm done. There's nothing really more to do. But I want us to really look at our coefficients here. Notice, and let's try to see if we have a GCF. Now, we've talked about this a lot too, but let's see if we have a GCF. Notice I have my coefficients are a 3, a 6, a 6, and a 9. What number, if any, is the greatest common factor of all those numbers? And if you said 3, then you're absolutely correct, because all of these numbers are divisible by 3. So we can actually simplify this fraction or this division problem by dividing everything here by 3. So if I take 3 divided by 3, it's just going to give me 1. So 1x. Really, I don't even need to put the 1. Then I have positive 6 divided by 3, which is positive 2. Okay. And then down here, I'm going to have 6 divided by 3, which makes that 2x, okay? And negative 9 divided by 3 would be a negative 3. So this is a more simplified version of what this fraction here is. Again, fraction is nothing, division problem is nothing more than a fraction. Fraction is nothing more than a division problem, okay? So this would be my answer for this one. But this is actually going to bring me to something that we need to talk about, okay? So there are some numbers that will not work for x here in this particular problem. And here's what I mean by that, okay? If we look at these other problems that we have, notice this one is a quadratic, right? These we could consider, both of these, number 1 and number 2, we could consider linear. And so if, for example, we were to go back and graph, each one of these are functions, remember. So if I were to graph this 9x minus 3, and I'm going to do that really quick here in Desmos. If I were to graph 9x minus 3, I see that it is a linear equation. And if I'm thinking about the domain, remember the domain is my x values, well, this thing goes on forever in both directions, okay? So my domain for number one, okay, my domain for number one is going to be negative infinity to positive infinity. And as a matter of fact, it's going to be the same for this one because, again, it's a linear equation.